All right. So, first we'll cover the last subtopic which is left, and then I suppose that we'll be done with the entire chapter. So the last subtopic for enzymes is immobilized enzymes. So basically, अगर मैं आपको एक diagram बनाती हूँ, and then you'll be able to understand instead of studying all of this English. Let's just do this diagram. Okay, let's suppose if this is an enzyme, ठीक है? And this enzyme is surrounded by something like this. So don't you think that have we encompassed or enclosed this enzyme with a external protective coating? This is basically the entire idea of immobilized enzymes, that we mix the enzyme with a particular solution. It could be of anything which is inert in nature. Inert means unreactive in nature. So particularly for your syllabus, we are concerned with sodium alginates, that we pass the enzyme with sodium alginates, and then this particular sodium alginate encompasses your enzyme, and this way we say your enzyme has become immobilized. Okay. So if you want to write a proper definition, okay, what exactly an immobilized enzyme is, then you can write immobilized enzymes are those whose movement in space has been restricted completely or to a small limited region. And there's a reason why we do so. Okay, what is the need of immobilizing enzymes? And this question often comes for 4 marks. I'll let you know all the pointers that you need to mention. So basically, the process of enzyme immobilization is that you confine the enzyme molecules to a solid support over which your substrate is passed and converted to products. ठीक है? And why we do so? So, in order to prevent your enzyme from degrading or deactivating, we immobilize it, and to enhance its stability and to make sure that your product is not contaminated with the enzyme. So basically, if you have immobilized your enzyme, that does not mean that reaction won't take place. Reaction do take place, but there with that particular covering, and since that covering is inert in nature, so it's not going to react. But we just use it in order to protect the enzyme from any degradation or deactivation, and to enhance its stability. And it's also easily separated. So there's no such issues that we face by immobilizing enzymes. Okay, so if you want to write these pointers, you can write it. Okay, it's not written over here because it's a very small subtopic given in your Mary Jones, the book you follow for A levels. बस यही सब चीजें हैं. And the questions that come are, okay, why do we immobilize enzyme? So it's economical. Number one, economical. We can continuously use enzyme in whatever ways that is possible. Number two, it is a convenient methodology because it's easily separatable, and it improves the stability of the enzyme. And since these immobilized materials are inert, so we prevent the loss of enzyme activity by not changing the chemical nature of the reactive groups in the binding site of the enzyme. So this is just it. And with that, you have completed your this chapter, enzymes. Okay. So, acha, the important economical application of immobilized enzymes is, you see that there are a few kids that are lactose intolerant. So markets do have lactose-free milk for them, right? So this is exactly because of that immobilized lactase. We get milk free of lactose and lactase. So this is the very economical consumption of immobilized enzymes, that we pass the milk from the beads that contain this immobilized lactase, and since it does not contaminate the product, we obtain milk which is free from lactose and lactase. ठीक है? Have all of us understood?
Yes, ma'am. Yes.
All right, perfect. Okay, so I'm starting with the past papers. So yeah, and if Minha, you'll struggle in any concept, then we'll go back to the slides since you were not present. Okay, so simultaneously we can do a small revision, and we can also attempt the past papers. All right.
Thank you.
All right. Okay. So we'll find few of the questions that are mixed up with some other chapters. We'll skip those and we'll just remain confined to those which only have the concept of enzymes. So number one, enzyme inhibitors are monoclonal. Let me see. Inhibits. Tika. So basically, Minha, before starting this question, we have few inhibitors. These are competitive inhibitors and incompetitive inhibitors, and they're responsible to halt the reactions. And there are two types: competitive and non-competitive. So if I show you this picture, it will be easy for you to understand. There's this chart that there are two types of inhibitors. Number one, competitive. So competitive inhibitor. Wait, let me show you this diagram. See, inhibitors are responsible to halt the reactions, right? So one thing that you would observe in competitive inhibition is that the inhibitor is of similar shape as to that of active site, meaning the substrate and inhibitor are complementary to the shape of active site. So if inhibitor will bind with the enzyme, the reaction will not take place because this is not an enzyme substrate complex, right? So we do not have any such thing like enzyme inhibitor complex. So no product will be formed in this reaction. But this is a reversible reaction, meaning that if we increase the concentration of substrate, then there's a likely chance that substrate will bind with the enzyme and your enzyme substrate complex will take place, and eventually you'll get the desired product. Okay, so this is your competitive inhibition where rate of reaction will decrease. But since this is a reversible process, as you increase your substrate concentration, there's a likely chance that your substrate will bind with the enzyme. And the primary thing that you need to remember for competitive inhibition is that the inhibitor is of similar shape like that of substrate, which binds to the active site, and this is how your final product is not made. But for non-competitive inhibition, this is a non-reversible reaction, and the main difference between both of them is, okay, I said that for competitive inhibitors, they have the same shape as that of a substrate, and they bind with the active site. Here, your non-competitive inhibitor binds to any other site other than your active site. So any other site other than active site within the enzyme is known as allosteric site. So what happens is when this sort of non-competitive inhibitor binds with your enzyme will lose its 3D shape. It will become deformed. Okay. So see, this is the substrate. This is not the substrate. This is the non-competitive inhibitor. But it did not bind with the active site. It binded to the allosteric site, which is the site other than the active site. And when it will bind, this will cause a non-reversible change, and your substrate will lose its active site and it will eventually deform. Make sense?
Yes,
Miss,
competitive is a non-reversible and it has the same shape as an enzyme and binds with the active site. And
Hmm.
non-competitive is a reversible reaction and it does not bind with the active site, but it changes the 3D shape.
Non-competitive inhibition is the irreversible process because since you lose the active site of enzyme, you'll not get it again, right? So this is a non-reversible reaction. Oh, sorry, this is an irreversible reaction, while competitive inhibition is a reversible process. Okay?
Okay.
It's a non-reversible, irreversible, and this one is a reversible reaction. Say yeah?
G.
Hmm. Okay. So now let's see this question. Enzyme inhibitors and monoclonal antibodies can be used in the treatment of a disease. Mevinolin is an enzyme inhibitor that can be prescribed as a drug to reduce the concentration of cholesterol in blood plasma. High concentrations of cholesterol in the blood have been linked to an increased risk of cardiovascular disease. Mevinolin acts as a competitive inhibitor of the enzyme HMG-CoA reductase. Do not worry about these Hoffnack names. Okay? They'll give you these names. Just stick to the concept. They're talking about a competitive inhibitor right now. So this enzyme catalyzes one of the first steps in the synthesis of cholesterol shown in figure 6.1. So HMG-CoA, and this is this enzyme, and you get the product. Explain how mevinolin inhibits the enzyme HMG-CoA reductase. So this is a 3-mark question, and they've already mentioned, okay, this is a competitive inhibitor. So what exactly are you going to write in it?
मिस मेविनोलिन की शेप HMG एंजाइम से सिमिलर होगी, तो एक्टिव साइट की जगह ये इनहिबिटर आके बाइंड कर जाएगा और फाइनल प्रोडक्ट नहीं बनेगा।
फाइनल प्रोडक्ट नहीं बनेगी, ठीक है. सो डू यू वांट टू go ahead and write it and then share your script with me? Take a minute and then just write the important pointers. Do not make the entire script because it's for your own practice. You can write that HMG co A, your mevanolin inhibits the enzyme HMG-CoA reductase because of the specific and the same shape. Specific, this is a keyword, specific or same shape as that of active site. Same shape. My writing went into air. They had this complementary shape to the active site, binded with the active site. Number 2, this is your important keyword, that it binded with the active site. Binded with site. Then what else can I write? Binded with the active site, and this is why HMG-CoA, the actual substrate, was unable to bind with the active site and mevalonic acid production decreased. Okay. So your substrate did not bind it did not bind and you did not get your product. So the product which was mevalonic acid and it decreased. ठीक है? Make sense?
मिस जब वो हमें इस तरह के एग्जैक्ट देते हैं क्वेश्चन, लाइक उसमें मेंशन है नेम प्रोडक्ट्स वगैरह भी, तो हमें ज़रूरी है कि हम यही वर्ड स्पेसिफिक यूज़ करें या हम जर्नल भी बता सकते हैं?
Try to use the specific words because आपको वो सिर्फ डरा रहे हैं ना, तो आप डरे नहीं ना, आप यूज कर लें. आपका एंजाइम ये था HMG CoA reductase, ठीक है, दिस वाज योर एंजाइम, एंड इसके साथ कौन सी चीज आके बाइंड हो गई है? This mevanolon was your inhibitor. It binded with HMG CoA reductase. It had the specific same complementary shape with the active site, which resulted in your substrate not being able to bind with the active site, and इसकी वजह से the production of mevalonic acid decreased. ठीक है?
यस.
ओके सो अच्छा, ग्राफ्स के क्वेश्चंस आर वेरी इंपॉर्टेंट. ये तो आपके पेपर में फॉर श्योर आते हैं. ठीक है, तो इसका तरीका ट्राई टू अंडरस्टैंड बिकॉज इसमें बहुत इजी होते हैं मार्क्स लेना. इट्स नॉट वेरी डिफिकल्ट. Researchers isolate a sucrase enzyme from the bacterium. They immobilize the enzyme in alginate beads. The researchers investigated the effect of temperature on the activity of the immobilized sucrase compared with the activity of the same enzyme free in solution. The results are shown. So they have given you this key. The line with crosses has immobilized sucrase, while the line with dots have sucrase free in solution. Okay? These are the two lines. Acha, now what you need to do is, I assume it's a 3-mark question. No, it's a 4-mark. With reference to figure 3.1, compare the effects of temperature on the activity of immobilized sucrase with the activity of sucrase free in solution. So you just need to compare the effects. You need to see few of the, you can mark like few of the numbers of temperature, and then you can compare the activity of immobilized sucrase. Okay, so it's a 4-mark one. Now you can write 4 pointers and this will be 8. You need to correlate your temperature with the percentage of maximum enzyme activity. Okay, initially the reaction started at 40 degrees Celsius with your concentration. I am assuming what exactly this concentration is. I need to zoom it. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I assume that 5 small boxes is equals to 70. 1, 2, 3, 4, 5. If my eyes are working correctly, so this is 70 degree. Oh, this is 70 percentage of the maximum enzyme activity. You need to figure out what exactly this value is. And then you need to mention कि which activity, which
96.
it's 96 or 86?
76.
Oh, 76, yeah. ठीक है चलो, it's if this is 76 of percentage, it started off with the exact same at 40 degrees Celsius, then you need to make a comparative analysis कि immobilized had more activity or the one with sucrose free in solution had more activity. You need to give proper values and take a lead on it and just try to answer it. नहीं होता तो I'll let you know. You can make a generic statement initially that activity initially increases and then decreased for both of them. Both had maximum activity at, I believe, both are showing maximum activity at, I think this one, this is like 60 degrees Celsius. Yeah, both have the maximum activity at 60 degrees Celsius, and both of them exhibited the increase in the peak and then a decrease in the peak. Okay, these are 2 pointers. Then and you can write this pointer that activity is 76% at 40 degrees Celsius for both of them, and their activity decreased more steeply, right? So this is a more steeper decrease as compared to the increase. Increase is not as steep as the decrease. Okay. And what else can you write? I believe these are like the 4 pointers. And then you can
और
give,
मिस सुक्रेज जो है फ्री इन सॉल्यूशन वो 80 सेंटीग्रेड पे डीनेचर हो जाता है क्योंकि
या
जीरो एक्टिविटी है.
हाँ, यहाँ पे आप लिखते हैं कि यहाँ पर जो है वो 80 डिग्री सेल्सियस पे सुक्रेज शोड जीरो एक्टिविटी. और यू ठीक है, सो द फर्स्ट पॉइंट इज कि एक्टिविटी इनिशियली इंक्रीज फॉर बोथ ऑफ देम. And पता है these have the same format. All of the graph questions have the same format, especially for enzymes. यही बातें जो है घुमा फिरा के you'll have to write exactly the same things. So activity increased and then it decreased for both of them. Okay. So try to get full marks for this question at least, because इसमें you do not have any different format. And you can write at 76 degrees Celsius. Oh, no, not 70 degrees Celsius, 76%, but you were having 40 degrees Celsius for both of them. At 40 degrees Celsius, 76% of maximum enzyme activity can be seen for both. Okay. Then you can write at 60 degrees Celsius, both of them showed maximum enzyme activity. 60 degrees Celsius per maximum enzyme activity है. And the point that Usman gave के 80 डिग्री सेल्सियस पर एक डीनेचर हो गया and एक inactive हो गया. So this gives you 4 on 4. 80 degrees Celsius
Okay.
per. Yeah.
Can you please check my answer in chat?
All right, just give me a minute. Sucrase free वाला जो है free became denatured. Make sense? ठीक है, excellent answer. Usman, Minha, have all of you understood? Can we move on?
मिस ये जो इमोबिलाइज सुक्रेज है ये 80 सेंटीग्रेड पे फिर भी एक्टिविटी तो है इसकी थोड़ी सी.
इसकी तो नहीं है, फ्री वाले की तो नहीं है.
जी मिस मैं इमोबिलाइज की बात कर रहा हूँ.
इमोबिलाइज पे हाँ 26 डिग्री सेल्सियस आ रही है ना. लीस्ट हो गई ना, कम हो रही है, टर्मिनेट होने की तरफ जा रही है. ओके,
ठीक है.
चले. अच्छा जी, नाउ दिस इज another question. Figure 3.2 shows that immobilized sucrase remains active over a wider range of pH compared with sucrase free in solution. Suggest reasons for the higher activity of immobilized sucrase over the range of pH between 5.5 and 8.0. ठीक है. So अच्छा, इसको एनालाइज करें बिकॉज थोड़ा सा टेक्निकल एस्पेक्ट इसमें पूछा है. अगर मैं इसको छोटा करूं, ठीक है. इसको थोड़ा सा एनालाइज करें एंड वील डिस्कस इट टुगेदर।
मिस मुझे आपसे क्वेश्चन पूछना था।
जी
मिस इन सब ग्राफ में इमोबिलाइज वालों की एक्टिविटी ज्यादा देर तक रह रही है क्या, इस वजह से क्योंकि ये ज्यादा प्रोटेक्टेड है?
ज्यादा प्रोटेक्टेड है, एग्जैक्टली आपने यही आंसर दे दिया है इस सेकंड वाले पार्ट का। ये इमोबिलाइज की क्योंकि इट हैज प्रोटेक्टिव लेयर, इट हैज अ स्टेबलाइजिंग इफेक्ट, ठीक है, एंड दैट योर एंजाइम इज नॉट एक्सपोज्ड टू द सॉल्यूशन सो इट कैन बी यूज्ड ओवर एंड ओवर अगेन, ठीक है। Or you can also write the shape of the active site of immobilized enzyme will not get disrupted easily, and that your active site is complementary to the substrate. And this is it. I think ये कितने marks का question है? This is a 2-mark question. So 2 pointers would be sufficient that these alginate or these immobilized enzymes have protective covering, which increase the stabilizing effect, and that your enzyme is not exposed to the solution. So the shape of active site is not disrupted. And bas, should I write it? It's protective. Protective. Usman, make sense?
यस बस।
Protective hai. So it has a stabilizing effect. Your active site is not disrupted. Stabilizing. Shall we move on?
यस
जी।
ठीक है. State one variable that the researcher should keep constant in both investigations and explain your answer in terms of enzyme action. So what could be the variable that should remain constant in both?
अमाउंट ऑफ एंजाइम,
Amount of enzyme, excellent.
टेम्परेचर,
और
Temperature,
पीएच लेवल
सही है.
पीएच
pH, आपकी concentration या volume of enzyme, ये substrate, pH, temperature. टेम्परेचर तो खैर वेरी कर सकता है, बट आई थिंक
मिस
जी
पीएच तो हम देख रहे हैं, तो पीएच कैसे कांस्टेंट रहेगी?
पीएच अगर उसमें वी ट्राइंग टू इन्वेस्टिगेट ना, तो पीएच तो सब में सेम नहीं है, सबके लिए सेम है, बट इनकी एक्टिविटी इज डिफरेंट, राइट? उन्होंने सेम एंजाइम्स पर डिफरेंट डिफरेंट एक्टिविटीज को कैप्चर करा है, नहीं? देखिए ना, 3.0 है, फिर 3.5 है, फिर 4 है, एंड देन 8 है। तो 8.0 पे वी गेट कि यहाँ पे एक की 0 एक्टिविटी हो रही है, एक की 20 जितनी भी एक्टिविटी है, आई कैन नॉट सी कितने एक्टिविटी है, पर देखे ना हम लोग वही तो मॉनिटर कर रहे हैं, बट विद द सेम पीएचएस दैट आर गिवन वी हैव मॉनिटर्ड डिफरेंट एंजाइम एक्टिविटीज, राइट? तो पीएच वाज सेम बट एक्टिविटी वाज डिफरेंट। समझ आया?
जी।
So, Usman, since they have already given the pH, you need to write something else because pH की तो already यहाँ बात हो गई है. So, you need to write यहाँ पे concentration of enzyme या substrate जो है वो same होनी चाहिए.
मिस टेम्परेचर भी लिख सकते हैं इधर?
लिख सकते हैं, टेम्परेचर लिख लें, टाइम लिख लें, टाइम टू डिटरमाइन द एंजाइम एक्टिविटी। ऐसा ना हो कि एक की एक्टिविटी आपने 10 मिनट बाद चेक करें, एक की एक्टिविटी आप 5 मिनट बाद चेक करें। सो टाइम कुड बी योर वेरिएबल, दैट शुड बी कांस्टेंट, योर कंसंट्रेशन शुड बी कांस्टेंट फॉर एंजाइम्स, ठीक है? टाइम, एंजाइम, पीएच की इसलिए नहीं लिख रहे हैं बिकॉज पीएच ऑलरेडी गिवन है, एंड ऑल्सो द टेम्परेचर। ऑल राइट, एंड व्हाट विल बी योर एक्सप्लेनेशन फॉर दिस?
सो कि जो हम चीज मेजर करें एक्टिविटी वही सिर्फ चेंज हो, बाकी कुछ ना हो, कोई फैक्टर इफेक्ट ना हो।
एक्सेलेंट, ठीक है जी। All right. So suggest 2 advantages of using immobilized enzyme in industry other than remaining active over a greater range of pH. So they have already mentioned कि pH के अलावा कोई और बात बताएं. So what can you write?
मिस इकोनॉमिकल होता है।
Economical है, convenient है. It can increase the shelf life of enzymes. Shelf life यानी कि it can be used over and over again, and it does not denature if your temperature increases because it's encompassed in a protective layering. ठीक है? Number A, it is economical. B, it increases the shelf life of enzyme. C, it does not denature if the temperature increases. So these are lots of points that you can add.